Okay, so I'm happy to introduce Víctor León, the last speaker of this afternoon. Víctor is a professor at Universidade da Integração Latino Americana, also known as UNILA, and he will speak about integral conditions for the existence of first integrals for analytic deformations of complex saddle singularities. That's the title, not the abstract. So, Victor, please go ahead.
I want to thank the organizers for the opportunity to give my presentation. It's showing with work Bruno Escarda, the Universidad. We study the formation of ramified analytic this means a singularity given by the level of the function here f equal x, y in C2 cross Cn minus 2. For this sake, we shall consider one parameter analytic families of one forms. Wt equal dxy plus some j bigger or equal 1 t power j omega j, where omega j in germ the holomorphic the 1 for holomorphic Cn to orange.
So I'm confused. Fxy in C2 times Cn minus 2, what does that mean?
Now origin.
X and y are the variables on C2.
Is yes. F on yeah. Tá. Então, we shall study under which conditions the deformation admits a holomorphic first integral. We denote if C como sendo of the level hypersurface xy equals C. We denote the line integral of the one form omega t, how long the closed path gammas. We shall mean a continuous closed path in FC. The main result let families be an analytic by integral one forms of the complex saddle df equals 0, where f x y x analytic deformation. Then the following items are equivalent. The line integral of the one form Wt equals 0 for all gamma c, for all c próximo 0 for t. T German to 0 is equivalent one form omega t se escribe esa forma a t de df más derivada de kt para todo t ct where a t I got ht in holomorphic function Cn of the parameter formal. For n bigger or equal to 3, if the two form omega t wedge ddf has singular set of codimension different one at the origin Cn cross T. Then about conditions, simply there is a one parameter holomorphic first integral for omega t. This means there is a holomorphic function f Cn cross Ct see, shear such that edge restriction FT Q F QT is a holomorphic first integral for WT and F0 equal F. This motivation of the theorem is a version of the main results. For example, Ilyashenko. This study cyclone limits of the ordinary differential equation. Escardua is the study of case on no-decretal singularity, dimension 2. Consider deformation, the pencil by plus condition then multiform integral. Musinho. It's about the formation of meromorphic pencil. Some examples. Below are examples that show the condition, the codimension of the singular set, different one. No? We consider family omega t, d dx y plus t x y squared dx. The line integral, the one form, no long, c, no difficult, 0, omega t wedge dxy equal d x power 3 epsilon no y square dx wedge dy. Codimension singular set this one form does not admit allomorphic first integral for t different of 0. omega t quotient, which is y squared, equal the xy quotient xy squared plus t dx equal the minus 1 cosine xy minus dx. The existence of a pure meromorphic first integral for t shows that this foliation admits non-holomorphic first integral. Servo-Mattei. Second example, generalization of the simple one. Consider omega t equal exponential ty dxy plus dxy dx. The line integral of the one form omega t along C, 0. Omega t wedge the xy equal the x squared y dx wedge dy. Codimension singular set of the two forms. One. But now admit holomorphic first integral. The proof, omega t does not admit a holomorphic first integral. The proof is based on the computation of the first terms of the homology method of the separatrix y equal to 0, and showing this map is now finite according to the Mattei-Monsieur. This implies that there is not holomorphic first integral for the foliation. The other example. The next example shows that result is non-valid for saddle of the form f equal x power p y power q. Consider omega t equal xy z squared y power 3 quotient squared y power 3 equal those y the x minus 3 is 3x dy. Isso vai ser omega 0. A deformation is equal omega 0 minus t lambda in C different to 0, G omega 0 plus T de x. A integral, a line integral of omega t how long of the curve gamma c equals 0. Equals 0. Claramente va a satisfacer a condición. By omega t has a first integral of Liouvillean type. Given by not necessarily holomorphic. Example 4. We consider one form of the classical formal models due to Martin and Ramis equal 1 plus lambda minus 1 xy y dx minus 1 plus lambda xy x dy. Consider analytic deformation of the omega of the saddle xy, no? To form integral line omega t how long gamma c equal minus tc integral linear integral of the y dx different to 0 by the Green-Stokes theorem. By the one form, not a holomorphic first integral. Martinez Ramis. No? The proof of the theorem in dimension 2, the K length let one form, holomorphic work form, equivalence. Then the following. Condition are equivalent. Eta writes as the form for where AH in holomorphic again to CIRM equivalent the line integral eta ao longo gamma C equal 0 for all gamma C xy equals C tudo C. In dimension 3, is necessarily used by arguments for Mattei Monsieur. Outro que let one form into manifold, holomorphic one form into connected complex manifold. Assume that one omega is integral line integral of omega along gamma for every gamma in for every one cycle. Then for every one cycle gamma in M. Equals 0. Yeah, equals 0. Then omega is closed. 34 exact. Lem2 plus extension theorem of Berthier-Servoz. Bom, eu acho que parar aqui. finish.
Thank you,
Consigo
Victor.
falar inglês.
Questions, comments?
Respostas em português. Vou responder em português. Hein?
So you consider like you start to a foliation that is d of the first integral is xy, but can you do this with do you know any similar result for another kind of first integral and then you do this deformation?
Bom, entendi. Você está... Qualquer outra coisa aqui? Ah. Eu dei exemplos aqui das condições ali. Tem que ser uma célula não ramificada, porque senão, se você consegue uma ramificada, você consegue que não tenha integral primeiro.
It is difficult for us to follow the conversation.
I'm sorry, I was just mentioning that the novelty here is that the singularity of the initial term is big, has codimension 2, right? Because if the singularity is larger, x, for instance, x squared plus y squared plus z squared, as initial term for the deformation, then this kind of result follows from Malgrange's Frobenius avec singularities, avec singularité.
Yes. O que eu queria falar aqui, que bom, a chave é provar isso em dimensão 2, né, que são equivalentes. Dá para fazer isso, a família é um parâmetro, a mesma coisa. Agora, quando a dimensão é maior, então você precisa usar as ideias de Matei-Monsiuk, construir uma imersão holomorfa em posição geral com d de x, y, com essa one form.
Do you want a translation, or could you get the remarks of Victor? He wanted to add something to his talk, so he's saying that in dimension greater than 3, he uses techniques from Matei-Monsiuk, the building immersion in general position with respect to the problem, to try to apply the techniques there and then extend afterwards. So do you have any other question or comments or requests?
Yes, so you were, Victor, you were almost talking about so techniques from Berthier and Cerveau, and so you need this is an ingredient for the proof of the theorem. That's it?
Não entendi. Vou usar. É um ingrediente, é porque...
Yes, it's an ingredient for the proof of the theorem. The key lemma, indeed.
Okay.
Por esse fato disso daqui, olhando a família de deformações, né, nessas condições, que se tenha isso, por exemplo, isso que o lema 2 diria que eu consigo que ômega t wedge de xy seja 0. Isso acrescentado com isso, cortando com um prolongamento de C2 CN, pegando aqui a forma, né? Pegando aqui. Nessas condições, dá para usar o lema do Berthier-Cerveau. Considera novas coordenadas. Dessa coordenada. E olhamos para essa nova forma aqui. Você pode provar que essa nova forma aqui, ao longo desses novos ciclos contidos aqui, essas novas coordenadas, se anulam. Por ver que estamos em dimensão 2, utiliza aí o lema que não acabei de enunciar, de Berthier-Servo, que basicamente, vou escrever aqui só para... Não? Bom, com esse lema a gente consegue resolver. Mas para encontrar a integral primeira...
Muito obrigado.
Mas para encontrar a integral primeira, é justamente o que o Jordi estava falando, que usamos Malgrange em dimensão alta para um sistema de formas.
Further questions, comments? Okay, if not, have a nice evening, bon appetit, and let's thank the speaker again before you go to dinner.